Hey my colleagues, welcome back to my channel. Today I bring to you another ansys tutorial on how can you do harmonic response analysis by using ansys workbench. So as you know the drill, the problem description is explicitly given on this on the display. So as you see from the description, the structural steel material has a property like modulus of elasticity, Poisson ratio, and the density. So as you see from here, this steel bracket and its front face profile is given. So its extrusion depth is 12 centimeter. So for anchoring purpose, a screw hole of diameter 1.5 centimeter is centered on the bracket flat ends. Suppose the bracket is fixed on the bottom and is subject to a harmonic pressure load of magnitude 1000 Newton per centimeter square on the top face. So at the end, we try to extract the frequency response of the directional deformation. That means along the front face normal direction of the front face of the bracket under the given harmonic growth. So as you see from the diagram, all the magnitude or the dimensions are given. So all those dimensions are in centimeters. So in this video I'm gonna show you how can do this step by step. Keep watching. To start this, let us open ansys workbench. So as ansys workbench will open like this. So since we are doing a harmonic response analysis, so as harmonic response analysis required a modal analysis as a prerequisite. So we start our analysis on the modal. So let us double click on this modal analysis. Once the modal is open, the project schematic will display like this. So to start this, let us check our engineering data. Let us double click on the engineering data. So our material is structural steel. So by the way, structural steel is a default material for ansys workbench. So this structural steel has a magnitude, has the property of the density 7850 and the Young's modulus 200 megapascal, the Poisson ratio 0.3. So it fulfill our requirement, or that it's the same with the material on the problem description. So we can proceed to the project. So let us open the geometry, double click on the geometry. Design modeler will open like this. So the first stage on our sketch is adjust our unit first. So let us select centimeter as a unit, then let us select one plane and start our sketch. Then let us apply some constraints like equal length, since it is symmetry, as this and this are equal, as this and this are equal. Then let us dimension it. So this is 12 centimeters, this is 8 centimeters, and this is one is 8.5 centimeters. Then let us modify. There are some fillets, so the fillet radius is 3. Then between this line and this line there is a fillet. Between this line and this line there is a fillet. This line, again this line, again this line and this line. Then let us generate it, and then let us extrude this. As the extrusion depth is 12 centimeter, and let us take it as 18 surface, as 18 surface. So the inward thickness is 0 and the outward thickness is 1.5. The thickness of this bracket is 1.5. So let us generate it. So this is the material see the geometry we created. Then there are holes as this and this surface for anchoring purpose, so we have to create that. So let us select this plane and then let us dimension it. And this is 6 centimeters. Then let us extrude this. From the operation, let us select the cut material, and then the depth is 1.5. Then let us generate it. We create this hole. Then similarly, let us create on this face. So we create the geometry, then let us close the design modular and proceed to the model stage. So double click on the model. The mechanical and workbench will display like this. So for the time now, let us accept the default mesh and then let us generate this mesh. And then from modal analysis setting, we can change the number of modules. Let us make 10 for the time now. And then from modal, let us insert fixed support. This face and this face are fixed. And then we can, if you solve this, we can get the first 10 natural frequency of this structural steel bracket. So if you click on the solution, you can get the first 10 natural frequency of this structural steel bracket. So those are the first 10 natural frequencies of the system. So if you do this, we finish the thing what you have to do in the model analysis. So let us close this and workbench. And then let us drag the harmonic response to the solution stage of model analysis. So we are sharing the engineering data, geometry, model, and some setups. So let us refresh the setup of harmonic response. Double click on the setup. So the workbench will display like this. So from harmonic response analysis setting, let us adjust the minimum and the maximum range of frequency. So as you see from the result of, let us solve this model again. So if you click on the solution of modal A6, so those are the first 10 natural frequency of the system. So the minimum is 1600 something, and the maximum is 10,000. So from the harmonic response of analysis setting, let us adjust the minimum and the maximum range of the frequency. So the minimum is, let us take the minimum, and then the maximum will be half of the maximum modal natural frequency of the system. So let us make it 5,000. Then from our harmonic response, let us apply the harmonic pressure on this face. So before that, let us adjust our unit. So metric is our unit. So with the magnitude of 1000 megapascal. Then if you want to see the frequency response deformation, so the geometry, let us select this front profile of the bracket, and then if you solve this, we can get the frequency response plot. Once the solution is done, if you click on the frequency response, so this is the plot of the frequency response, or the amplitude versus frequency, or the natural frequency of the system. That means the frequency due to harmonic pressure. So starting from 1940 up to somewhat around 5000 hertz. So this is the amplitude versus frequency graph, and the lower one is the phase angle versus frequency. So as you see from for some value of frequency, the phase angle will vary from 0 and 180 degree. So this is how can you do or how can you get the frequency response plot. So if you click on frequency response, then insert, then from this, if you want to create the counter results, click here, and then if you solve this, if you evaluate this, we will get the directional deformation due to this harmonic pressure. So if you want to animate this, let us click here. So this is how the structural state bracket will deform due to the harmonic pressure of 1000 megapascal. So this is how can you do a structural harmonic response analysis by using ansys workbench. I hope you get something from this video. So if you get this interesting, and if you want to be updated throughout, please subscribe my channel. For the time now, thanks for watching my videos. Thank you.